Hello everyone, welcome back to Maths and Math Tricks. I am Lakshmi ma'am and here I am back with yet another session for the paper NDA 1 2018. We are solving the questions of set A paper. Alright, let's begin with question number 71 now. In this question, we are supposed to find out which one of the following is a correct statement in respect of the function f, which is defined from R to R plus, and it is defined as mod of x plus y. So we wanted to find out, does the statement A correct for the function f of x, or B correct, or C correct, or none of the above is correct. So talking about each statement individually first, let's talk about the first A statement. When you check out the left hand side, f of x square, what will be f of x square? You can see it is mod of x square plus 1, and this is definitely not equal to mod of x plus 1 the whole square, isn't it? So statement A says that f of x square is equals to f of x the whole square, which is absolutely incorrect, because the expansion of mod of x plus 1 square will not be equal to mod of x square plus 1. So the statement A is incorrect. Talking about the statement number B, f of mod x will be clearly what it will be. Let me tell you, it will be mod x plus 1. Now, it's clear to see that this is not equal to mod of mod x plus 1, isn't it? This is clearly not equal, because here the modulus part is to the x, and here the mod part is to throughout this x plus 1, and it has got the modulus. So, when you go to apply the definition, okay, when you apply x less than 0 criteria, it going to be, this part mod of x plus 1 part going to be differently validated, and mod of x plus 1 will be validated differently. So you can cross check that. That's why the statement number B is incorrect, absolutely. Okay, talking about the C, which is clearly incorrect, you can see that the C part here telling us that f of x plus y, what it will be mod of x plus y plus 1, which is clearly not equal to mod of x plus 1 plus mod of y plus 1. That is clear to see, everyone, right? So statement C is incorrect. So what it has to be correct here is option D only. Hence the right choice for this particular question is option D, because none of the above three statements are correct in respect to this function. Alright, moving on with the next question now, number 72, and here we are asked to find out the range of the function x square upon 1 plus x square, which is defined from R to R. Very first of all, when it been asked to find the range for a given function, what triggers in your mind should be that what is the minimum and the maximum value function takes. So basically the closed interval a comma b we define to be the range of the function, where a is the minimum value taken by the function and b is the maximum value taken, and there are the values taken by the function between these two values. So basically here you supposed to imagine such an interval, okay, for the function, and hence determine what is the range of this function. So for that you can clearly see the function definition simply telling you x square by 1 plus x square. This is always a positive function. The minimum value of this function turns out to be 0. Can you agree upon that? And this is valid at x equal to 0. And any x you give, x less than 0 you give, x square is positive, 1 plus x square is positive always, so it's going to be a positive number. So there is no chance that a function will take a negative value there. Any input you give, the output will be always a positive. Only for the input 0, the output is 0. So the minimum value we got it here, minimum value for the function is 0. What could be the maximum value? Can we determine that? To determine the maximum value, here we can have one clarity that this x square part is strictly less than 1 plus x square part, because 1 is a positive number and 1 plus x square a positive number which is bigger than x square. So it's clear that x square by 1 plus x square clearly will be always less than 1. So we got an upper bound for this function, that this fraction x square by 1 plus x square will be always less than 1. So basically the maximum value is just below 1. Okay, the maximum value is just below 1. So you can clearly now see in the options that close at 0 is required. So it is there in the option A, B, Okay, so C and D strike out. But out of A and B, the correct option is option A, because you can see the maximum value is not 1. Function can never be 1 here. It will be just below 1. That's why we got the range over here. What is the range of the function? It is the semi-closed interval 0, 1. This is the range and it is provided in the option A. So option A is the right choice. Moving ahead with the next question, number 73. And here we have got the function f of x defined as the sum of the two functions mod x and mod of x minus 1. We are asked which one of the following is correct. Is it that the function is continuous at x equal to 0 and x equal to 1? Is it that function is continuous at x equal to 0 but not at 1? Continuous at 1 but not at 0? Continuous neither continuous at 0 nor at 1. So first of all, to answer all such questions, guys, what you have to remind is simple thing about the function mod x. You have thoroughly studied this function, how the graph look like for this function. At x equal to 0, it's 0, and for x less than 0, the output values are negative numbers, and for x greater than 0, the output are positive number. This is what the graph of the function mod x looks like. So now you can see that this function is clearly continued. You have already studied that this function is continuous at x equal to 0. So if I have now such another function mod of x minus 1, can you visualize, suppose this is 0 and this is here 1, so this function starts, both this left side output taken and the right side output taken, these two lines meets at x equal to 1. So this is how the graph of mod of x minus 1 will look like. So basically this function will be then continuous at x equal to 1, because this function mod x is continuous at x equal to 0. So mod of x minus 1 will be continuous at x equal to 1. Not only this, guys, you always remember whenever you encounter all such a function. So this basically a function which will be clearly continuous at x equal to a. So if you remember this fact, that is sufficient. In 1 second or 2 you will answer all such questions in your examination. So remember, hence here the correct choice is the option number A, perfectly guessed, that it is continuous at x equal to 0 as well as at x equal to 1. Alright, moving on to the next question now, that is our next question number 74. Look at this, we have given a function f of x which is defined to be x square ln mod x for x non-zero, and it is predefined to be 0 when x is 0. Alright, and we are asked f dash 0. Now to evaluate this, you must recall the definition, h definition you must recall. So it is defined as limit h tends to 0, f of h minus f of 0 upon h. This is a derivation, the definition. This must you derived already when you studied the concepts of derivatives after the limits concept. So this is the limit based definition of derivative to evaluate for a function at the indicated point, and here that point is 0. So this is how it is evaluated. Remember this definition, limit h tends to 0, f of h minus f of 0 by h. Now let us evaluate this. So this is equal to basically limit h tends to 0, f of h, calculate f of h, it will be h square ln of mod h minus f of 0 will be clearly 0. For f of h we have written h square ln mod h, and for x equal to 0 here you can see f of 0 we have to take it to be 0, so I am taking 0 there. So upon h, so you can see this h's get cancelled, and what we are getting is limit h tends to 0, h into ln of mod h. Now you people will tell me I have to substitute the limit or what? Yes, that is what you do, but understand the meaning of limit. H tends to 0 means here h is not equal to 0, it's a very small number approaching to 0. So mod of h will be a positive amount, and ln of positive amount is always defined. So this is a defined number, some defined number k, and h is here 0, we can substitute. So 0 into some defined number k will be 0. So alternatively then here we are getting the value of f dash 0 is equal to 0 only. Alright, so option A is the right choice. Coming on to the question number 75, here we are asked to find out the area of the region bounded by the parabolas. Two parabolas we are asked to find the region enclosed between. Okay, so very first what we have to do is we have to find the points of intersection of these two parabolas. So you can see y square equal to 6x minus 6 and y square is equals to 3x. So by solving this, you're going to get 3x is equals to 6, x is equals to 2. Alright, x equals to 2. So when x is equals to 2, we have to find out respective y value. So you can choose either of one curve to find out y value. So let us choose the simpler one. X equals to 2 means y square is equals to 6. So y is equals to plus or minus root over 6. So basically now sketching the curves, how does it look like? Let us take, we have got the parabola number 1, which is y square equal to 6 into x minus 1. You can see the vertex of the parabola is 1, 0 here. Say this is 1, 0 point. So this is how the parabola is, and this is my parabola y square equal to 6 into x minus 1, whose vertex is 1, 0. Now the another parabola there is, that is our y square equal to 3x parabola. So let's have a look at that parabola. How does it look? The vertex is 0, right, 0, 0, and both are going to meet at some point. Okay, that point of intersection, I mean those points of intersection we have already calculated. Let us mark those 2 points. This point will be, this is basically x equal to 2. They are meeting at x equal to 2. The y is positive root 6 over the first quadrant, and in the fourth quadrant it is 2, minus root 6 coordinate. Isn't it? So this is the required area we supposed to find out, enclosed between them. So we can simply take the formula of finding the area in terms of, the limits as a limits of y ranging. So y is basically ranging from minus root 6 to root 6. So basically you people know, right, that how do we evaluate the area? To evaluate the area, what do? We will write the formula. Here we are getting integral minus root 6 to root 6. These are the values of y. So I have to express my function in terms of x. So here what will be x equal to? It will be y square by 6 plus 1, right, and here y square by 3. So minus y square by 3. So this is my function in terms of y coordinate I have written. So I have taken the limits of y. So when you write the function in terms of x, like when you say y equal to f of x times you write, then you will take the limits from x to x. Okay, so what do you get now? Let us evaluate. What do you get? Let us evaluate this integral. So this is basically area is equals to root over minus root 6 to root 6, y square minus y square by 6 here, there by 3. So we have to eliminate. Let us simplify this. The LCM is 6, right? So what do we get? 1 minus, what do we get? Here we are multiplying by 2, 2. So 1 minus 2 minus 1. So it will be y square by 6. So this will be the simplest function that we have arrived. Now substitute, integrate first and then substitute the limit. So y minus y cube by 18, limits minus root 6 to root 6. So what do you get? What do you get now? So this is equal to basically root 6 minus root 6 cube will be 6 root 6 by 18, minus root 6 you are substituting now. So it will be plus root 6, then minus it will become plus when you substitute at this point, and there is a minus from outside, no? So this will be still minus what it will be, isn't it? Am I right? See, when you substitute the lower limit, you take the minus, right? So this is minus root 6, which becoming plus because of this minus, and then this minus and this here minus, so that is becoming plus, fine, but this minus is there, no? So it will be left over. So minus root 6 cube will be minus 6 root 6, okay, 6 root 6 by 18. So you can see the simplification now. What is the simplification? Turns out to be, it will turns out to be 4 root 6 by 3. You can check. See, you simplify this. Basically you are getting this is as 2 root 6 minus root 6 by 3, root 6 by 3. So it will be 2 root 6 by 3. Right, 2 root 6 by 3 to the 6, 6 minus 2, 4. So it will be 4 root 6 by 3, and hence I told option is C valid here. Alright, moving on to the next question, number 76 and 77 for that, and 78 also, because there are 3 items now we are supposed to answer based on the information provided. that there are 3 sides of trapezium which are equal to 6 centimeters. So basically 3 sides are equal means how does the trapezium look? There will be one side which will be the longer. So yes, then I would take this and this side to be the 6 each. So the fourth side is I am unknown, this is the side which is unknown to me. And as these two sides are equal, I would say this is the trapezium which is called to be isosceles trapezium. It is not now normal one, isn't it? Alright, so I am going to put now heights. So let us draw the perpendicular from this point on the opposite side, from this point on opposite side. So you can see this is isosceles trapezium. So this portion is x equal to this portion which is also x. Alright, so and we have given there is an angle alpha which is between a pair of adjacent sides. So I would take this angle to be alpha. Is that fine? Just it's an angle between two adjacent sides. Any two sides you can take, but this is very perfect for us to take to handle the answerings. Alright, so what is asked? Come on to the question. We are first of all asked what is the value of alpha, keeping in mind that the area of the trapezium is maximum possible. Now, first we have to work out for the area of trapezium to utilize this condition. Isn't it maximum criteria of the area? So what is the area? Let's come on back to the diagram. What is the area formula? Tell me. What is the area of the trapezium here? Area of this trapezium is equals to half into h into a plus b. This is what the formula you studied. A and b are the two opposite sides. H is the height. So here the height is unknown. So it's still h I am putting. A and b, can you see? A and b. A is 6. B is unknown. B is certain. Say this is 2x plus y. I have to find out the values of here h, x and y so that I can get the properly the this y, yes, y is to 6 only, right? So why I am taking y is 6 only. I can see here there is a square form, I can see here there is a rectangle form. This 6 is equal to this opposite portion 6, so this much is 6 only. So basically here only x and h is unknown. So half into h into 12 plus 2x, perfectly fine. Now let's talk about this h. I can use the Pythagoras criteria here, isn't it so? So I can have there then 36 is equals to x square plus h square. So h is equals to, it is a positive amount because it's a height. So it's a root over 36 minus x square. So basically I have got the area value now. Area in terms of x, half into h I have got root over 36 minus x square into 12 plus 2x. This is what I have got. If I reduce this 2, I would get the area equal to 36 minus x square under the root into 6 plus x. So this is what I have got the area. I have told that if area is maximum, then what is to be found? That is the alpha angle. Alright, alpha angle to find out I can take the help of trigonometry, but there is a x unknown. Can you see the diagram? To find out the alpha I have to make use of this right triangle. So here x is unknown. No? So if I get that x, I am done. So working upon to that, I have given area is maximum. So then I know that, what do I know? I know that the first order derivative must be equated to 0. So what is the first order derivative? This is my function now f of x. What is f dash x here? F dash x is equals to uv rule. So it will be basically root over 36 minus x square into 1 plus 6 plus x as it is root derivative. You know root x derivative 1 upon 2 root x. So it will be 1 upon 2 root over 36 minus x square into again composition minus 2x, right? So this is the derivative. This is I am equating it to 0. So what do I get? I'll get the denominator portion equal to 0 there, and if I simplify, I'm going to get 2 into 36 minus x square, because this will get multiplied with this, minus this 2x into 6 plus x. Hope you are understanding the simplification part. So this is how going equated to 0. So how much then? 36 2s are 72 minus 2x square minus 12x minus 2x square equals to 0. So I am basically getting that quadratic equation minus I am taking out. So 4x square plus 12x minus 72 is equals to 0. I can reduce the numbers. Divided by 4, what do you get? You will get the equation x square plus 3x minus 4, 1, then 32, right? So 9, isn't it so? 9, right? 8, sorry, 4, 18 equal to 0. So what are the factors? 6 3s are, so I am getting x plus 6 and x minus 3 equal to 0. So basically here x is what? Part of the length, it cannot be negative, so I have to choose x equal to 3. So if x is equals to 3, coming on to the diagram back, here I can work out for the unknown alpha. So for this unknown alpha, I can take, what I can take, I would take sine alpha. If I take sine alpha, I would get opposite and the, okay, I would take cos alpha because adjacent is the x part, no? So I would take cos alpha. So cos alpha, if you take the adjacent is x and the hypo is 6. So x we got 3, so this will be equal to half, and that is, you know, true for pi by 3 angle for cosine 60 degree, isn't it? So we got the answer then. What is the answer to this particular question? It's option number C, isn't it? Option number C is the right choice. Coming on to the next part, 77, here we are asked what is the length of the fourth side. What was the fourth side? The remaining side, right? You saw that is like x plus 6 plus x. That was the remaining fourth side. Because that side only the unknown, right? So x we got 3. So basically it's 3 plus 6 plus 3, then what it has to be? 12. That is option D. Coming on to the next part, number 78, and here we are asked what is the maximum area. Area we know, what was that function we have got? We have got the area function, which is root over 36 minus x square into a plus b. What was that? 6 plus 6, 12, na? 12 plus 2x. Let me recall. Let us not go wrong anyway. Okay, coming on to the diagram back, the area function, what we have got the area, this is what we have got the area. We have simplified, right? This is the area, 6 plus x. Okay, 6 plus x. 6 plus x. This was our area. We wanted to find out now what? We wanted to find out the maximum area. So maximum area for x equal to 3 itself. At x equal to 3, we will get the maximum area because the area was maximum for x equal to 3. That is what we find out. This was the stationary point, isn't it? Application of derivative. You must remember the concept, right? So x equal to 3, let us calculate. So this is basically 36 minus 9 into 9. So 36 minus 9 going to be, yes, 27. 27 means 3 root 3 into 9. So we are getting here 27 root 3 square centimeters. Alright, so for 78th question, hence the right answer is option C. Got it? Moving on to the next question, number 79, and here we have to evaluate the integral. Definite integration this question is from. So first of all, let us talk about the integral. So let's say I is equals to integral e power x sin x. You can use the Eilert rule, right? I cannot give the e power x to the function u. I have to choose sin x as the u function because it will regenerate again back in the process. So I will get this I back. So for that I am choosing, let me write for you uv integration. You all remember uv integration is like u into integral of v minus integral of v into derivative of u into integration. That is how you process. So with this knowledge, moving on, we have here I is equals to e power x integration is e power x, so it's e power x minus integral of e power x. What is the derivative of sin x? You will get cos x there. Again you are proceeding with this integration in the same uv format, choosing the Eilert rule. So I am writing it again. So it is e power x sin x minus, when you say now the integration part of this e power x into cos x, here again your u is cos x. So you are getting e power x integral e power x cos x as it is. Then when you go cos x derivative is minus sin x, no? So this minus will become plus there and it will come out to be integral integral e power x sin x. Isn't it very much clear, right? So let me rewrite for you this part. So it is e power x sin x dx. So when you are now applying this minus, so this portion is minus I, so it will add it to the left hand side and it will become 2i. So right hand side we have e power x sin x minus e power x cos x. So I have to work with this part. That's it, to evaluate the integral. So I just need to now evaluate the integral by substituting the limiting values. I have already calculated the integral part of it, right? Integration I have already done. So now that's why I'm now calculating here for you that the given integral equals to 1 by 2 times limiting value portion for e power sin x, e power x sin x minus e power x cos x. Limits from 0 to pi. Let us substitute these limits. What do we get? Half. When you substitute 0, this portion is 0 because sin 0 is 0. This portion is minus 1. Okay. When you substitute 0. But first we have to substitute pi, right? Upper limit. So when you substitute upper limit also, sin pi is 0. So we are basically getting minus e power pi cos pi. Cos pi is minus 1. Right? Cos pi is minus 1. Now let me write. So this is done with the upper limit. Now minus lower limit portion. When you substitute 0, the first value is 0 minus the next value. E power 0 is 1, cos 0 is 1. So it is 1. So this is what you are getting. So what do you get the answer? What do you get the answer? Let us simplify. What answer do you get here? You will get this is equal to half minus into minus plus e power pi minus minus plus 1. So you are getting basically e power pi plus 1 upon 2, and that is provided in the option number A. So option A is your right choice in this question. Alright, moving on to the next question, number 80. And this is going to be last question of this session, and I'll be continuing with the further questions in the upcoming session. Alright guys, so moving on to this with question number 80 here. F of x is known to us, which is a fractional function, and it is continuous at x equal to 3. So what is the definition that function is continuous at x equal to 3? It is said that f of 3 is same as limit at x tends to 3 for f of x, isn't it? This is how the definition of continuity is. So continuity is, so f of 3, let us calculate that. We are asked to calculate that only in all the 4 options. So this is basically limit x tends to 3, f of x square minus 9, I can split it as x minus 3, x plus 3. Check. And denominator factors you can see minus 3x plus x. So basically it is then x plus 3, right? X minus 3, and because the factors for this minus 3 will be minus 3 and what, because the middle term you want minus 2x. So x minus 3 and what it has to be? It has to be x plus 1. So you can see x minus 3 is getting cancel. X minus 3, what are you cancelling? X minus 3, yes, x minus 3 is getting cancelled. So what we are getting? Limit x tends to 3 for the function now x plus 3 by x plus 1. You can substitute directly limit here. See, the function is defined well at the indicated point. So this is 6 by 4. 6 by 4 comes out to be what? 1.5. Check, it's a 3 by 2. 3 by 2 is 1.5. So hence the right choice for this particular question is option B. Hopefully the solutions are clear to you. Stay with me for upcoming session and keep learning. All the very best to you.